Welcome everyone. Welcome to another workshop, WEkEO workshop. Today we are here to talk about coastal studies and how you can access WEkEO and study the coastal environment with the data we provide via WEkEO. My name is Andreia Carvalho. I'm a training officer at Mercator Ocean International, and I'll be your host for today's session. Before we start, I will give you some guidelines for the session. We are using Zoom for this workshop. You can use the chat in Zoom to speak with us and to ask small questions related to logistics or some sort of technical problems. For the questions to our speakers related to the workshop, please use Slido. We will provide the link to Slido session in the chat, and you can also access Slido via the website slido.com, and if you type in this code, you will have access to the question session, Q&A session. Some more guidelines about today's and tomorrow's session. They will be recorded, so if you're not able to stay for the whole session, don't worry, you will be able to watch it later on in our YouTube channel, WEkEO DIS. And the same for the presentations. Our speakers, we will also share it with you in an email you will receive later on. And now I'm going to tell you about the agenda for today. As I said, we're going to talk about coastal environments and how you can study the coasts through Copernicus data and through our platform WEkEO. We will have Florino from Lobelia, who's going to tell you about the catalog you can find in WEkEO. We're going to have Cédric Giodan, who's our user support manager, and he's going to tell you about how you can access the help desk and how can you send your questions to our user support team. And he's going to tell you a bit about the website as well, how to access certain facilities in the website. And then we're going to have two very interesting use cases on coastal studies, and from Clara Armaroll from the University of Bologna and from Etiënne Kras from Deltares. So without further ado, I will just give you an overview of what is WEkEO about and what you can find in a general term on WEkEO. So if you're already familiar with the Copernicus, is the EU program for Earth observation. And the WEkEO DIS is a data and information access service for the Copernicus environmental data. So it was developed, is a cloud-based platform developed to facilitate and standardize the access to the Copernicus environmental data. So you can have access to, besides the cloud platform, that you can have access to the data, the harmonized data. You can also have access to a virtual environment that you can, where you can process your data. And you also have access to a very skilled user support where you can ask specific questions related to your studies. WEkEO is governed, or it is managed by the different entities that also manage the different Copernicus services. So we have Mercator Ocean International for the Copernicus Marine Service. We have ECMWF for the climate change and atmospheric Copernicus services, and EUMETSAT, who are involved in the managing of the satellites, Sentinel satellites, which are the group of satellites we are highly dependent on for the Copernicus data, and the European Environment Agency for the land service. So this is just another display of how we work in WEkEO and how can you access WEkEO. So you go to wekeo.eu, there you will have access to the different services, the data, the computing environments, and more information also on use cases. So as I said, you have a vast catalog in WEkEO. Today we will show you a little bit more about the data you can find related to coastal studies. And so the main access of WEkEO is that you have access to Copernicus data, which are not a copy. You have access to the data displayed in each of the different services directly. This data is accessed in a more harmonized way, so it is in a more similar format, and it is more easily retrieved. And as I said before, you also have access to a very skilled user support who will help you with all your questions. So for free, you can have access to the Copernicus data. You can download the data, and you can have access to a Jupyter environment where you can run some computing, and also to some storage. If, on the other hand, you are a more expert user and you would like to have access to more machine capacity, computing capacity, you can have access to a paid plan, and you can also discuss with our WEkEO providers a more interesting plan for you if you're a university or a company to have access to a high performance machine. So this is just another demonstration of what you can find in WEkEO, and you can also search on our website. You will find more information about that. As I said, you have access to a Jupyter environment, and you can run some analysis there. You also have access to a Jupyter notebook gallery where you can learn from previous workshops where we have presented several other studies, marine, land, from the different services, Copernicus services. And as I said, you have access to virtual machines as well if you are a more expert user or you don't have access to computing platform. This is our user support. So Cédric, Giodan will tell you a bit more later how you can contact them and also find articles that explain it to you how to install certain softwares you would need or other things. We have a YouTube channel, as I mentioned in the beginning, and there you will find other short videos, tutorials from previous workshops, but also short videos on how to access the viewer or the Jupyter notebook gallery, etc. And that's all for me for the moment. Now I'll give the floor to Crtistian Florino, our first speaker for today, who's going to tell you a bit more about what sort of coastal products you can find in WEkEO. The floor is yours.
Thank you, Andreia. All right, so as Andreia has said, I'm the current data portfolio manager, and my role is having a look and understanding what is sort of the product availability, what's available, if there are any issues, and sort of keeping track about evolutions of the plan and so on. So currently, as of today, I think there are 438 different data sets available through WEkEO, which is quite a lot. And today what I will present is just a few of the data sets that are most related to coastal studies. There might not necessarily be strictly coastal, but there might be global, but important to the coast as well, to have sort of like an overview. So starting service by service, and starting with the land monitoring service, just a quick overview of what this service provides and has. And first of all, it has like different components, one global, one pan-European, and one that is more local, based on basically the area that they cover and the different purposes that they feed. But they also provide imagery and reference data as well. So having a look at some of the data sets from the land monitoring service that might be relevant. So the water bodies product detects areas that are covered by inland water around the globe, and it can be useful for monitoring maximum and minimum extents of water surface in the context of seasonal dynamics and studies. Then the EU Hydro is a data set. It's available for all of the EEA countries, providing a data set that is taken from, well, it's basically the river network and combined with the interpretation of water bodies as well, lakes and rivers, and also with a drainage model. So it's quite useful for river catchments and lakes as well as drainage. Then we also have the WEkEO dam, which is a digital elevation model to see the elevation of the land. Another quite interesting data set that you can find in WEkEO is the coastal zones land cover and land use, which sets out to inform about the European coasts, all of it, and how the land, what's the land cover, what's in it, and how it is used, having different categories, categoric values that will inform you about what's that cover and use. The high resolution layers is a pan-European data set as well that provide information on a specific land cover characteristics as well. It is complementary to the previous data set as well, and together with the Korean land cover data sets. And they are produced from satellite imagery through a set of automatic processing. So it's quite another level of processing compared to the previous one. Continuing on, there's the snow and ice monitoring as well. Again, this is not just coastal, but it can be very important for the coast as well. And it has information about the fraction of land that is covered by snow or ice. It has to do with sea ice as well, the type of snow, whether there's persistent snow over time. So it's not just whether there's snow or not, it's many more variables as well. Then we also have the dry matter productivity. Again, this number is the resolution, but there's also in 1 kilometer as well as the daily water bodies. There's also different resolutions. Well, the Natura 2000 is a network of core breeding and resting sites for rare and threatened species, and also rare natural habitats. So it's this network of different areas that are to be protected. So they have an extensive monitoring of them. So this network of areas stretches across the 28 EU countries. And basically the network aims to ensure the long-term survival of the most valuable and threatened species. Similarly, we've got the riparian zones, which are those transitional areas occurring between land and freshwater ecosystems that they have distinctive hydrology and also different soil and biotic conditions and conditioned by stream water. So, and anything related to those riparian functions can be found in this particular data set. And finally, there's the Urban Atlas, which similarly provides pan-European land cover and land use data but focused on functional urban areas. Again, this is just a few details of some of the data sets that can be relevant in terms of land monitoring. But if you explore the platform, you will see that there are many more. Moving on to CMEMS, the Copernicus Marine Services, just a quick overview. There's 3 main components of the service related to the oceans. One is the blue ocean, related to the physics. Green ocean, more related to the biogeochemistry of the ocean. And finally, the white ocean, which has to do with sea ice and snow. In the physics, you can find anything from temperature, salinity, currents, waves, which might be quite relevant for coastal studies, as well as sea surface elevation and wind. And then, well, the biochemistry, you've got anything related to nutrients, plankton, oxygen, and so on. And as we said, the cryosphere would fit into the white ocean. Some of the data sets, well, anything with the biogeochemistry, reanalysis, and forecasts. So this is, you can look back in time to see what were these properties in the past, but there are also 10-day forecasts for these properties using models. and you can find anything related to, as I said, nutrients and plankton and so on. Similarly, the physics reanalysis and forecast would do the same, looking back in the past with those reanalysis, and again into the future with the forecast for the physical properties. Another interesting data set that you can find is the related to waves. Looking back and into the future as well, it's quite interesting that you can, for some applications, you can have that view of what are the forecasts for the next few days. There are also, well, I forgot to mention that these are mostly global, but there are also data sets specific to the Mediterranean, the North Atlantic, the Black Sea, the Baltic Sea, and a couple more places. So similarly, that's the case for the in situ near real-time observation network, which you will find a lot of in situ observations from, it can be from floats like Argo floats, from moorings, or from platforms, from many different instruments, and they will provide almost real-time data from those platforms with some quality control and processing. Another one, there are different data sets that have different processing methods as well. So if you're interested in these, you can check the description of these data sets in the platform to see which one is more suitable for you. There are several data sets that look at ocean color, OT, and process that into climatologies and daily observations of chlorophyll and plankton, different nutrients, and so on. That's the case, for instance, for the Copernicus globe color as well. L4 is for the level of processing, so you will find level 3, but also level 4, which is the sort of highest processing, gap-free and interpolated into a regular grid. Again, you've got some data sets that are specific for some regions. For example, the Baltic Sea surface ocean color plankton, which is based from Sentinel-3, but also complemented with OT L4 monthly observations. And you can also find the European seas graded L4 sea surface heights. So to see what's the, I think these data sets, the gravimetry, the sea surface, the mean surface, and calculate the anomalies, the differences over time to see how that surface has been changing. And yeah, some other specific data sets for temperature, and other specific data sets for the Black Sea, the Mediterranean, and so on, again, for temperature. But there are many more data sets that might be suitable for you. This is just an example from another presentation where you can see, for instance, a snapshot of the mass concentration of chlorophyll A from the biochemistry analysis and forecast, and also the sea ice fraction at the Northwest Passage from the White Ocean component. Moving on to the climate change surveys. In this case, there are a lot of data sets as well that can be quite related for coastal studies. They include in situ observations from weather stations and balloons, from all the records as well. They combine that with satellite observations, and then also with models. And combining all of these different tools, they provide different data sets that can be quite interesting. Okay, so having a look at some of these, you will find that there are a lot of risk indicators or climate indicators. For example, we've got the extreme precipitation. So in that case, this data set presents climate impact indicators related to extreme precipitation in Europe under current climate conditions. It includes recent historic records, recurrence intervals, and all the relevant statistical measures to evaluate magnitude and frequency of these events. Again, you've got precipitation monthly and daily graded data for that period of time, derived from satellite microwave observations. Another quite important and quite used data set are the reanalysis, like ERA5 or ERA5 land. And I'll show a snapshot of that in a second. you will find there a lot of climate-related variables or even weather variables as well. From 1945, I believe, until present, with really high temporal resolutions. I think it's even to the hour. And you will find variables like wind, temperature, a lot of atmospheric different variables. And you can find them as well in pressure levels or heights or single levels, different ways of understanding the atmosphere. Another data set, another reanalysis is the EUERRA, which contains, again, atmospheric variables on high pressure single levels from 1961 to present. What else? There's the data set with the carbon dioxide in the atmosphere from satellite observations to see what's the concentration of that greenhouse gas in the atmosphere. Other data sets is the sea level daily grid data from satellite observations, more bioclimatic indicators, like similarly to the precipitation ones. Another one that can be quite interesting for some of the applications is the seasonal forecasts, which these ones set out to provide a long range outlook based on the changes in the Earth system. But it's not like a weather forecast, it's more of a seasonal forecast. What is in general, what is expected based on the predictability given by the long-term changes like of slow varying components of the system. So if you want to have an idea of how the next few months might look like, this is quite interesting for that. Other data sets have to do with windstorms, events, and heat waves or cold spells. So it really depends on the application of your particular studies. But again, these can be global, but they can be quite important for coastal studies as well. More indicators on temperature and precipitation, and again, some with hydrology related as well. And finally, some data sets related with the water sector, specific for hydrology studies and water quality as well for European rivers, and some about water quantity and availability in Europe, and some for specific big major European cities. As I was mentioning before, it's been a few weeks already that ERA 5 has become viewable on WEkEO, so you can explore these atmospheric variables that I was mentioning before. This is a list of some of the variables that you can find there, and this is how they look like on WEkEO. And I was wrong, they started in 1940, and it has hourly resolution. So you can check all of these variables since 1940s until present at an hourly resolution, which is quite big. And the next service is the atmospheric monitoring, a global picture of that. There's global data sets and analysis, and then others that are more regional, like forecast and reanalysis specific to Europe. There are supplementary data sets that have to do sometimes with the climate forcing used for those models and so on. And then the emissions, which has to do about global fire emissions and other anthropogenic or natural gases based on emissions. Looking at some of the data sets that can be quite relevant, there is the global atmospheric composition forecast. Similar to ERA 5, this one will have the different gases of the atmosphere, what is their composition, and I will mention this in a second as well in the next slide. There's the global emissions inventory, which contains greater distributions of global anthropogenic and natural emissions from various sectors and sources, but it's quite relevant for greenhouse gases, reactive gases, and aerosols. There's other reanalysis like EAC4, or the greenhouse reanalysis, EGG4. These are quite specific. And there's the European Air Quality Forecasts and Analysis, which is quite used. And finally, there's the biomass burning emissions based on fires, and the solar radiation time series, which is a long time series looking back in the last few decades about what are these the solar radiations, which is quite used for energy as well. As I was mentioning, this is the Global Atmospheric Composition Forecast, which is also recently viewable on WEkEO. These are many of the different atmospheric components or gases that you can find in that data set. And yeah, this is how it looks like on the platform. Finally, I will talk about the emergency services, and I think you'll hear more about this in some of the other talks. This service sets out to support all actors involved in the management of natural and man-made disasters by providing geospatial information to inform decision-making organisms and so on in cases of emergencies and so on. So they monitor Europe to forecast, analyze, and provide information on resilience strategies. There's on-demand mapping, but there's early warning and monitoring systems. And what you can find mostly on WEkEO have to do with floods and fires. There's river discharge, which is global and European. And there's also fire danger indices, just from providing global historical data, but mostly informing about this danger based on different climate factors. And that is a quick overview. Again, you also have the Sentinel products, which are more the data from the satellites, from the sensors, but this is a quick overview of some of the data sets that you can find for the different services on WEkEO, and some that might be more relevant for those coastal studies.
Thank you, Crtistian. Thank you for your presentation. So we have a few questions for you already. So we will try to answer as many questions as we can. Okay, so first question. All of the data sets mentioned are more restricted to European countries?
Right, so it depends on the different data sets and the different services. Some of them are global, but some of them are specific for Europe, and some of them are even specific to EU countries or EEA. For instance, if I go back to my slide, I think is the land services. They are quite limited to Europe. There are some global, but they are quite limited to European countries. But usually for the other ones, they are global in most cases.
Okay, or at least you have both options, is it? Like
Yeah,
European
I mean,
and
sorry, when I say global is that
Yeah.
you can access global data, but they're also specific for different areas, and they may have different resolutions as well.
Okay. Next question. Is there data for colored, dissolved, and detrital organic matter, CDOM, also available? Would you know of that?
I'm not quite sure at the moment. I should check that. I know that I think there's some data available, I believe. But
Yes.
what I do is I'll quickly check on the data set, the different variables available, and I can maybe send a message on the chat.
Yeah. Okay. Yeah, that will be cool. Yeah, you can definitely check. Well, we will see tomorrow a little bit more in depth how you can access the viewer and how you can search for specific data through the viewer. So that will be helpful as well. And one last question, or maybe one of the last ones. Is there data for sea level rise for Asian region, specifically for India?
I believe so. I think there is from the different sea level data set. That one's global. That's what I mean.
Mm-hmm. Okay. Would you know if there are any applications for saltwater plants such as eelgrass? Is there any application for saltwater plants? Maybe this one is quite specific, I think, right?
Yeah, it's quite specific.
Yeah.
By
Yeah.
applications that use this data. So that'll be data sets that might be relevant for a particular case, but I'm not aware that there's any application specific for this topic.
Yeah. Thank you. And one last one. Is there data available for sea level rise in the Mediterranean since the 80s, related to time series analysis?
I would think so, but again, with the other question, I'll check and come back to you to make sure that the specifics of the data set.
Mm-hmm.
So there's over 400 data sets.
Yeah.
So a good thing about the platform is that well, as Andreia mentioned, and when they show how to access these different data, there's the details of the data set that you can access, and you can see all the small print and all the different specifics of the data set, like the resolution, what data is available, what's the time span, and so on.
Yeah, exactly. So I think tomorrow, yeah, it will be more insightful in terms of how really to access the data and how to verify these details. Thank you. And I think that's all for you. In
Thanks.
terms of questions. Thanks a lot for coming, for bringing all this information.
Thank you.
Thanks a lot. So now we will have our first use case. That will be Clara, who's gonna tell us about ECFAS, the European Coastal Flood Awareness System.
Yes, thank you
Hi.
very much.
Hello.
Hello
Thank
everyone.
you.
So yes, indeed, this is the first use case of today, and I will briefly present the outcomes of the ECFAS project. That is a proof of concept for the implementation of a European Copernicus Coastal Flood Awareness System. And the project was a 2-year project that ended in December last year, and it involved 8 partners from 5 European countries. And it was financed under the Horizon 2020 Research and Innovation Action in a call for the evolution of the Copernicus services. And it was coordinated by IUSS in Pavia, Italy. The ECFAS project deals with the evolution of the Copernicus Emergency Management Service, and it aimed at providing a fully integrated risk cycle monitoring service. So starting from the early warning component, the awareness component of the preparedness phase, it provides tools and products that can be useful also for the response, recovery, and prevention actions. The main aims and results of ECFAS include the possible contribution to the evolution of the emergency service through the implementation of a European coastal flood awareness system. As you might be aware, the EMS includes an awareness system for river flooding, but it does not include an awareness system for coastal flooding. The ECFAS system provides up to 5 days forecast of total water level at pan-European scale. And it also provides flood extent and the potential flood impact at European level, considering different scenarios of total water levels. And ECFAS could also contribute to the improvement of the mapping component of the EMS through the products and tools developed, and also through the development and implementation of the shoreline analysis displacement in the aftermath of a storm event through the implementation of specific algorithms to the monitoring of the shoreline. It provides tools and algorithms for coastal storm risk assessment, and the final outcome is the ECFAS system itself, the web platform that is implemented using the WEkEO DS. And ECFAS produced a roadmap of integration into the EMS, and it's important to underline that users were involved from the beginning of the project to collect their needs and requirements in relation to an awareness system for coastal flooding. This is the general framework of ECFAS. As mentioned, it integrates different products from the Copernicus services, and the system itself includes two main components, the warning component and the mapping component. The warning component includes the total water level forecasts at pan-European scale, the identification of thresholds that are used to trigger the system, and the implementation of flood and impact information along European coastlines, and also new mapping products such as the shoreline displacement and the erosion impacts. As mentioned, the system was implemented through using also the WEkEO DS, and the involvement of the users was very relevant for the implementation of the products. And the final outcome is the web platform that I will briefly show today, and the roadmap of integration into EMS. For a proper risk assessment, the baseline important information is related to exposure and vulnerability of coastal elements. Therefore, in ECFAS, we implemented what we call the coastal dataset. That includes products and datasets from the different Copernicus service and other public datasets. This dataset has been quality checked, validated, clipped along European coastlines, and it is available in Zenodo and can be downloaded by the users. Then the hazard component was developed through the provision of up to 5 days forecasts of hourly total water levels through the Copernicus Marine Service. And the total water level includes different components and is computed along coastal points along European coastlines. And also the provision of thresholds that can trigger the coastal flood mapping and the whole system. And also the 1-year return period scenario is used to trigger the flood system, and other thresholds indicative of more intense storms were also computed. Then the system itself, considering that it has to include also the information not only of the hazard represented by the total water levels at the coast, it should include also information about the flooding extent along European coastlines and the forecasted or the possible impact of storm events along European coastlines. Therefore, we identified some extreme events in the past that were used to calibrate and validate the models implemented in the project. For the flood modeling, LIS-Flood was used. That is also the model used in EFAS, the European Flood Awareness System. And LIS-Flood was used to model coastal flooding using different scenarios of total water levels. And then an impact assessment method was implemented to compute the impact of different storms. And as mentioned, we integrated also a new, let's say, product that is not related only, the ECFAS itself is not related only with the flood impact, that is the main aim of the project, but we wanted to include also the erosion impact generated by storm events along low-lying coasts. Therefore, a semi-automatic tool was developed in the project. And this is named Shoreline Analysis and Extraction Tool that was developed by the Polytechnic University of Valencia. The tool, the algorithm is available for download in Zenodo, and it uses optical images, Sentinel and Lancet, to map the shoreline, and it can be used to evaluate which was the erosion impact and also the recovery in the aftermath of storm events. So how does the system work? First of all, the system works, let's say, offline, in a sense that when a storm is forecasted, there is not a real-time computation of the flooding extent and the probable impacts, but the system picks the information that were produced considering the different total water level scenarios. So the flood and impact catalogs are used in the system to retrieve the information related to the forecasted storm. So first of all, the system analyzes the information on the total water level, and then it checks if the threshold is exceeded. If the threshold is exceeded, then the sectors, the coastal sectors, are activated, and the relevant scenarios is then selected in terms of flood extent and possible impacts. The information are merged along European coastlines, consider the different sectors and the different scenarios. And then a warning is issued with NUTS 3 level aggregation. And similarly to what is done in IFAS, the warning level is defined considering the affected population, the number of affected people. So this is how the system looks like. At present, the ECFAS web platform, the proof of concept itself is not open to the public, it's still password protected. And the system includes several components and options. You can see here some screenshots of the system itself. On the left, you see the warnings, so the sectors that are activated after the computational chain considers the exceedance of the thresholds. And on the right, you can see the coastal points and the total water level computed along coastal points at European level. Then it's possible to click on a coastal point to see which is the time series of the total water level at the coast. And this is possible, this can be done along each coastal point represented in the map, in the European map. And then the system itself, includes the information about the flooding extent and the impacts that are forecasted for a specific event. And it is possible to display the information about the flood maps, which includes information on depth and velocities. And then it's possible to see also which is the forecasted impact along the areas that the warning is issued. And the impact includes different components such as the infrastructures, roads, main roads, railways, and buildings, the affected population, of course, and agricultural areas and other points of interest. There is also a download option where it's possible to download the information about the flooding extent and the impacts in the areas where a warning is issued, and the system allows a user to download information so that they can be used for different purposes. So thank you very much. If you would like to have more information, you can access the ECFAS website. I invite you to go in the node and check which are the information that are available for download. And if you want, you can drop us an email through this email address. Thank you very much.
Thank you, Clara. I have actually a question. When is it already predicted when ECFAS would be open to like a actually established system? As you said, it's just a proof of concept for the moment.
The project ended in December last year, so we are in the process of let's say the integration procedure. That our aim is that the system itself could really contribute to the evolution of the emergency service, that it could be open and integrated, but of course the process takes time, and we are working on that, and we hope to be able to open the system as soon as possible.
Yeah, I hope so. So too, it's a very useful system. And then I have another question. Well, so for the moment, we don't have any questions from you, from the participants, but I'm taking advantage to ask all my questions then. You said, so when there's a certain risk of flooding, an awareness is issued. Does that mean that then entities in each country will be, I don't know, contacted, or how is it that thought, or was that thought by ECFAS already, or will that be another service doing that?
Yeah, the system itself is meant to be integrated in the EMS system, so it could become a new service, a new, let's say, could integrate what is about the awareness for river flooding, so to include also coastal flooding. So it will follow the procedures already prescribed in the EMS. So the authorized users, civil protection, so we receive notifications, etc. So in practice, the system, this is to show how the system could work, which are, we developed several products that are already available. And we developed a framework for such a system. And then if it will be integrated, it will have, of course, to be integrated in the procedures already in place, already active in EMS.
Yeah. Okay, there's just one question that popped in. Which data do you use to predict risk of flooding?
We developed for the full risk, so we started from the total water levels, and then we developed different scenarios considering different storms with different intensities and durations. And then we use list flood to model the flood extent along European coastlines, dividing the European coasts into sectors of 100 kilometers of length, along shore length. And we used pan-European data sets. Because this is a pan-European product. So we had to rely on what is available, in fact, in the Copernicus services and other products, other data sets. And we used the high-resolution digital elevation model to model for the flood modeling. And the coastal data set that I've shown in the first slides was used to evaluate the probable impact, considering different let's say, the different scenarios and different, let's say, flood damage curves and so forth. So it's a sort of evaluation that is that includes both depth and velocities of flooding, of the model flooding along European coastlines.
Okay. And the data set you were mentioning, so then you access it through via WEkEO, so it was Copernicus data, right?
Was Copernicus data, yes. WEkEO was used for the virtual machines, for the storage, and so the system itself was developed by CLS and on their platform, but WEkEO was used for let's say, for the computing. So all the algorithms developed in the project to integrate the information, and then to merge the information, to display the warnings and so forth. So all the algorithms for the integration are run in WEkEO, and then everything is displayed in the platform.
Okay. One other question: would it be possible to predict the flood risk on a sector smaller than 100 kilometers?
The ECFAS system is built this way. It includes the sectors of 100 kilometers that are used also for considering the different sectors that are activated, and emerging is needed in order to select which condition is to be displayed in the different sectors, in the different coastal areas, including different sectors. But of course, all the products and the information used, starting from the exposure and vulnerability information, and then to the flood maps produced, yes, the answer is yes, it's possible. If you can, if you want to run your own flood model along coastline with a smaller extent and along shore length, then you can have different flood maps, and then let's say use the same framework to develop something similar, but at a higher resolution, for example, using higher resolution datasets, for example.
Okay, we have a few more questions popping in. For the communication protocols of each EU country, as they may have their own operational systems in place, which may not necessarily involve EMS.
This is a very important question, and I fully agree in the sense that this was an issue that we took into account during the project. Of course, we involved the users, so there was a specific questionnaire to understand which was the needs and requirement for such a system at European level, and we also did an analysis of what is available at European level in the different countries. As of course, there are procedures that are already in place, and this is not meant at all to replace any procedure that is in place. It is meant to provide information about the possible impact of storm events. And again, it builds on the framework of DMS. I know that if there are already procedures in place, this is not meant to replace or to, it can be a supportive tool, for example, it can be additional information as a background information, so you know that there can be issues in some areas. You can check what such a system can provide and then go into more detailed information at more local level.
Yes. What are the elements of coastal vulnerability considered during the risk assessment?
It's more about, let's say, the elements that we took into account. It's related more to exposure. So in the sense that we took into account what is exposed along coastlines and the characteristics of the exposed elements available in the data sets that we used to develop the risk maps and to develop the impact maps, sorry. And then we took into account also some information about the population, so providing the characteristics of the population. So this is something that we considered in order to have additional information about population vulnerability, for example. Indeed, the warning itself is more about the exposed, so the number of people that could be actually affected.
Risk.
Yeah, at risk, yes.
Very good. And that's all for you for today, I think. Thank you very much for your participation. Thank you.
Thank you.
And yes, if you have any other questions, I think Clara will be happy to answer them. We can maybe provide your contact in your presentation, maybe, or I mean, you have provided ECFA's contact, right? So yeah.
Yeah, indeed. But I have access to, I mean, I have access to that address. So if you want to drop me an email, I'm more than happy to answer and provide additional information.
Great. Thank you.
Thanks to you.
Now I'll introduce you to our next speaker. We'll have our second use case of the day. Etiënne Kras from Deltares, who's going to tell you about how we can monitor the coastal changes from space. Hi, Etiënne.
Hi, morning.
Welcome. Good morning.
Thank you for the introduction. Okay, so my name is Etiënne Kras. I work at Deltares, and I'm going to give a talk about the monitoring of coastal change from space, and then specifically about the Aqua Monitor and the Shoreline Monitor applications. And so a little bit about myself, as the topic is way more interested than I am. So I have a Master of Science in Coastal Engineering from the TU Delft, and I was fascinated by the complexity of the coast and its processes, let's say from a young age as a surfer. And later during my studies, I was also interested in monitoring the coasts from cameras and from space. So Earth observation, as well as big data analysis and machine learning. And in my current role at Deltares in the Department Resilient Ports and Coasts, I fulfill a role in bringing Earth observations applications into coastal and offshore engineering practice, while also dealing with the energy transition and climate change. So that's it for me. Let's continue, let's say, with the topic of today. So when we think about the coast, we usually think about it as a thin strip of land adjacent to a water body. And usually this is, we think of it as a nice sandy beach. And of course, it also has a socio-economic value. So it has a tourism, a recreation, but also provides ecosystem services like food, water, and biodiversity. In reality, actually, this is densely inhabited, and it's still growing. So if we look at the low elevation coastal zone, which is the land that is 10 meters above mean sea level, there are 600 million people living there in 2000, and this is projected to still be growing. So this is constantly under pressures from human, for instance, by land area changes, so dedicating land area to, for instance, housing. And then we also have climate change, so storms or natural hazards like sea level rise, and that also the processes that we have at the coast. At the same time, it's also difficult to monitor these environments. So these are very dynamic environments that change from minute to minute, but also from year to year and even longer time spans. And interventions, if we actually apply them without system knowledge, can have adverse effects. So this all calls for consistent spatial and temporal information where Earth observation can actually help us. So if we already have data at the coast, it is for sure not complete. So Earth observation will allow us to actually fill in the gaps, create a better system understanding, and then potentially also allows us to project our knowledge better into the future. So having that said, a bit about the background. So for our applications that I'm going to talk about today, I'm looking specifically to optical satellite imagery from ESA, but also from NASA. So for these satellites, we are capable of monitoring all continental land surfaces, so includes also inland water. Then coastal waters and shelf seas up to 20 kilometers from the shore. And then also the islands that are greater than 100 square kilometers. And then Sentinel-2 specifically, which has the multispectral instrument, we are capable of monitoring from 2015 up to today at a resolution from 10 meter with a 5-day revisit time at the equator. And we have 13 spectral bands. And Sentinel-2 actually supports Copernicus programs that are listed over here. If we include Landsat, which is a NASA satellite, then we are capable of going back all the way to 1984. If we look at the Landsat 4 mission. Some quick methodology. So how we move from satellite images to coastal change monitoring. We want to note that for some of these steps might be pretty complex, but this is because we built a global application. For more local cases, I think you will dive into this tomorrow. Some steps can be simplified a lot, actually. And so in order to move to this global application, we handle petabytes of data. So we access free data catalogs and then implement cloud computing and machine learning and advanced image processing technique to be able to deal with all this data. We are limited to cloud-free and daytime images because we use optical satellite imagery. So to give you a bit of a sense of what we actually are dealing with, these are just a lot of images for one specific area. So you see a lot of noise in this way. There's clouds, shadows, there's different water levels, turbidity, boats in the water column. We all need to deal with that on an automated basis. We usually use top of the atmosphere images, so that's the level 1C product, as we and the level 2A product is calibrated on land, and we are mostly interested in the processes at sea, so that's the water area. So we are doing the calibration ourselves, and in order to do so, we actually create what we call a composite image. So this is a clean and average image. And we do that by actually basically stacking all the images together in a certain time span, and then we remove all the clouds or the noise that we have in order to create a clean and average image. So we select the 15th percentile and then get rid of all the clouds and shadows that we have, and then we have the clean image actually. And then the final step is that we move towards the normalized difference water index, which is a combination between the green and the near infrared bands that allows us to better discriminate the land and the water areas in that sense. And so what you see in this picture. To make a little transition to the WEkEO platform, this is a screenshot from the platform itself. So if we filter on Sentinel-2, we do see the Sentinel-2 level 1C product over here. And if we click add to the map, we are prompted these options that we can visualize. And as you see, we do also see the NDWI index over here. So if we add that to the map, we see a similar picture as I just showed on the slide before, but this is the case for the Dutch coast. And then about the aqua monitor and the shoreline monitor. So I'm just going to give a couple of locations that are interesting to show over here. So for human interventions as well as natural processes or secondary effects. I'm going to give a live demo of the platform. So just talk about it in this slide very briefly, and then I'm going to switch screens. So what we usually do is we use the aqua monitor for qualitative information, which looks like the following. So we see green areas where water is transformed to land, and then blue areas where land is transformed to water. So this is actually erosion. And then quantitative information, then we use the shoreline monitor. So then we actually compute the boundaries of these polygons, which we call the shorelines. And then we get the lines over time. And we supplement the transact. So that's a cross-shore profile. We determine the intersections of these lines, and then we are able to show how the shoreline moved over time. And so I provide the links over here to both these websites and them combined. And now I'm going to just show you and talk you through it. So I do hope that you see this screen as well. So this is the aqua monitor. It's interactive in that sense. So if I move to the Dutch coast, to the sand engine actually. So what we see over here is the sand engine. So this was just a big pile of sand that the Dutch government put in front of the coast. So it was a mega nourishment, so of 20 million cubic meters of sand, which was placed in front of the coast for coastal protection. And the idea behind this mega nourishment is that the nature of natural processes would actually distribute the sand along the coast to also supply this with enough sand over the years in order to not to have to nourish every 2 years, for instance. And you do that, see that there's a lot of sediment also accumulating along the rest of the coast. Over here we see, of course, the land reclamation of the Maasvlakte 2 and the dredged channel to actually access the inner harbor. If I move further along the coast, we do see a lot of land that actually accreted over time, as well as also here shown for the harbor of Armaroll, where we have accretion on both sides because of the tidal movement going backwards and forwards. And if I go up here, we also have the Honsbosse Pettemer Zeewering, which was also a land or a big nourishment. However, we do not see it really over here, but if I toggle these items over here, we can get to dynamic view. So I can actually change the time windows that we have access to, and then show you the changes over time if I actually toggle on these layers. Here, if I show 2021, you do see there's a big area that was put in place in front of the coast, which is a land reclamation or a big nourishment. And you do not really see it in the static view, so we still need to see what goes wrong here. Anyway, we can also move to Bangladesh, which I showed briefly on the slide already. So this is a very dynamic environment. So there's a lot of meandering of the river, but it's also a very dynamic delta. And so we do see a lot of land areas that actually popped up. So these were water that were transferred into land, but also see erosive areas where there was land which are now water. So this was actually the last area that I wanted to talk about for the aqua monitor. Then we also have the shoreline monitor, which looks like the following. So here again, you can zoom into the Dutch coast, where we do see the transact system that we actually applied. So in this case, I'm able to actually click a transact and then get the time series information of the shoreline. That was dynamic over time. So we do see a couple of movements over here from smaller scale nourishments, and then in 2012 we see a big jump of a kilometer forward of the shoreline, which was actually the placement of the mega nourishment that we had over there. And then it starts to erode over time as it transfers sand to the adjacent areas. So if I click a transact at the side of it, this one is actually accreting over time because of the sand that is supplied by the mega nourishment. So some other locations that I actually wanted to show is in Australia, in Narrabeen, which is a very well monitored beach. And so we do see there's quite some let's say lines that are not that obvious, but if we click one, we actually do see there's a lot of changes over time. So it might be that the coast is not showing actually long-term changes, but it does show these changes over time, which is the interannual variability or the seasonal variability, for instance. So what I also wanted to show is that we do have some future shorelines over here, which is an effort from us that we wanted to see how our coast is changing over time, also in the future. So here we actually projected, let's say, the IPCC RCP, so the representative concentration pathway scenarios. So over here, if we click a point, we actually blindly extrapolated the ambient trend and then supplied it with the projected sea level rise scenario combined with the Bruin rule. And then you can see what your coast is suggested or potentially going to look like in up to 2100. And we are applying now machine learning models in order to improve this forecast that we have. Final thing that I wanted to show is that you can combine both products. So I have the best of both worlds in that sense. So I have both the quantitative as well as the qualitative information in. So if I zoom into the Dutch coast again, you do see that here I have this land area reclamation, or this big sand nourishment in here, but I also have the transact system available that I could actually click. So let me move back to my slides in order to move to the final slide that I have. So what I wanted to close up with is that satellite imagery provides us with a very big source of information that can enhance the understanding in data poor as well as data rich environments. It allows us to consistently monitor with a global coverage for periods of 50 plus years. If we include the NASA Landsat record, it has a high temporal resolution, order of weeks, and also a medium spatial resolution, order tens of meters. And then we could derive many characteristics of the coastal system from this imagery. So for instance, land water changes, but also shoreline changes, both static and dynamic. And it has connections to a lot of multiple other areas of expertise, for instance, the energy transition and nature-based solutions, but also the digital transformation. And what I finally wanted to end with is that the sources of satellite images will grow in the future. So this will even become more relevant. Yeah, that is all I wanted to say. So thanks for the attention. I can now answer specific questions, but if you do have general questions, I guess you can get in contact with the WEkEO support department.
Thank you, Etienne. Thank you for your
Welcome.
presentation. Yeah, we do have some specific questions. So the first question I can already start. You mentioned that products for surface of Earth, as opposed to TOA, are optimized for land, need to be corrected to be used in ocean areas. Can you elaborate?
Yeah, so this is a bit technical. So the level 2A, let's say, products, they are calibrated on land areas to provide, let's say, land monitoring services very well. We usually look at the coast, so then you have a complex interplay of also various water areas, and then we have to deal with breaking waves and things like that. So what we saw is when we were trying to actually compute shorelines along the coast for the global application, that we had a lot of trouble actually classifying these images. So we needed to start off with the higher level product, level 1C in this case, and then calibrate it ourselves, let's say on ocean areas, by using this composite image approach on the level 1C product. So we are not using these bottom of the atmosphere images, but rather the top of atmosphere images in that sense.
So next one is the satellite drift shoreline corrected based on datum, slope, and sea level rise?
That's a good question, actually. So because we use composite images, we create a clean and average image, let's say. So we are basically on mean sea level. And we do not really need a slope for this case in order to be able to actually produce the mean shoreline that we are computing every year. However, if we want to include, let's say, sea level rise, we do need the coastal slope. So for this, we use the Bruin rule, and we connect to another global data set on coastal slopes. And then we are able to project, let's say, the coastline into the future. And so for the historic shorelines, we are not using slope or sea level rise at all. For the future shorelines, we do.
About the historical shorelines, I think it was in that one. I saw that it was until 2016 or something. Is that the latest you have, or is it the goal to just be until 2016, or to include more data?
It's a good question, actually. So we were developing this product, let's say, in 2016, and then we published it in 2018. We actually have been deriving shorelines up to 2023. So let's say we get a lot of data requests through the portal that I showed, and then I can send you the information up to 2023. We didn't yet were able to actually provide this in the portal because we are at this point where we also want to revise, let's say, the backend of the portal. So we're working towards a new version that also shows shorelines up to 2023, for instance. And we do have it in the background, let's say, but it's not visualized in the portal yet.
Okay, but do you make it accessible in case someone What's
Yeah,
it
at the
about?
moment it's through data request. So you need to fill in a form and then I can send, let's say, snippets of the data sets that we have for specific countries, for instance, or specific areas, which is actually done quite a lot. So we get the 3 or
Yeah.
4 requests a month, which is somewhat 60 requests a year,
Yeah,
50 to 60. Yeah.
okay. I think that's all for you for today. No more questions. I think it was
Thank
quite
you.
clear, your presentation. Thanks a lot. It was very interesting. And we are almost reaching the end, but we have one more speaker. That will be Cédric Giodan. He's support manager at Mercator International, and he's gonna tell you how to access the user support. Yeah, post your questions and other things online. The floor is yours. Hi, Cédric.
Hello, everybody. Thank you, Andreia. So I'm Cédric Giodan. I'm user support manager of the WEkEO service. This short presentation, I'm going to show you how to find online resources, to learn how to use services available on WEkEO. So you should see the website. So there is a dedicated area for support on the menu here. But firstly, I would like to show you the Jupyter Notebooks catalog. You will have a demonstration tomorrow, but in this catalog, you will find several notebooks. You can sort by domain or platform, etc. And clicking on the title, you will find details how to reach and to use the notebooks. So I come back to the website. So I click on the support item on the menu. You will find 3 different boxes. I will begin with the last one, the system status. I click on it. Here you will find information on the unavailabilities or maintenances regarding the platform. So it's useful to have this to check this page if you encounter any difficulties. I come back to the support area. The second one is the data status. Here you will find the status of all data sets available. So it's better. The status of all the data sets available on the products available on WEkEO. And at the bottom, you will find a link to the service involved. For example, the service, normally in service, you will reach a page dedicated to maintenance, incident, etc. I come back to the support. Of course, here you have a form to fill in if you have a question or if you want to contact the user support. The last box is the help center. Is very important box because in this help center, you will find several collection on the use of data and services, how to download, explanation, details on HDA, etc. So you click on the collection and you find all the articles available. So do not hesitate to check all these articles because they are really useful and many answers are available in this article. So you click on for example, how to download WEkEO data. I click on the title. You have the menu on the right, and then you have many details to download data. If you don't have the answer question on the center, you can of course contact us directly. So you can contact us using of course the form as I told before, but at the bottom right of all the pages, you will find the chat. In this chat, you have a direct link with the help center here or here, following the icon help. And of course, there is a send us a message here. You click on the title and you can write, and you will meet Alexander or David or another member of the team, and we will answer as soon as possible. So do not hesitate to check the help center because it's really useful. And if you don't find the answer, please contact us, and we will be happy to answer you. Thank you very much.
Thank you, Cédric. Yeah, I hope this was clear to you how to contact us in case you have any question. And now we're reaching the end of today's session. So today we gave you an introduction to the WEkEO cloud-based platform. We told you about what sort of data sets you can find in WEkEO and to study coastal areas. And tomorrow we will have a practical session. Let me just tell you a few things about tomorrow's session. We will have David Pina, who's going to show you how to access WEkEO viewer, how to visualize data, how to download data. And we will have Alexandre Romerin and Daria Andreevskaya from Novelties, who are going to show you a few exercises you can perform using Jupyter Notebooks and QGIS using WEkEO data. Just a few reminders on the materials or the some sort of documents you will need for tomorrow if you want to follow tomorrow's session. If you would like to follow along the tutorials we will show, you will need an access to a Jupyter environment, which you can check online how to install it via some links we will provide in today's email you will receive. You will also have received the tutorial for tomorrow's session, Jupyter Notebook tutorial, as well as the QGIS tutorial. So don't worry, you will have everything on your mailbox today at the end of the day if you would like to follow our practical session tomorrow. Thank you everyone for your participation today, to all the speakers, Etiënne, Clara, Crtistian, Cédric. Thank you a lot for this introductory presentation on WEkEO for coastal studies. And have a good day, everyone. Bye-bye. Thank you.